No servus oameni buni. Sunt Hui Jing. Și voi vorbi despre... Nah, I'm kidding. This entire talk is going to be in English. I'm sorry if I butchered your beautiful language, though. I want to shout out Alex Lakatos for teaching me how to pronounce all those words. So today I'm going to be talking about web typography, which, may be fairly common, but I'm also going to talk a bit about non-English web typography, which hopefully is a little less common. So anyway, my name is Hui Jing. You can call me Jing. This is me in emojis. Make what you will of them. That fox is the closest emoji I could associate with being a Mozilla text speaker. There are a lot of us in the house today, so I know at least some people will laugh at my shitty jokes. And I also have a day job at Nexmo as a developer advocate. Nexmo being a platform that makes it easier for developers to integrate communications into their applications by providing APIs for messaging, voice authentication, that kind of thing. So, what is typography, right? It seems like almost everyone and their cat has a definition for typography. I mean, Wikipedia calls it the art and technique of arranging type. Matthew Buttrick, whose article is the first result you get when you Google what is typography. He got all the SEO juice going on for him. He defines it as the visual component of the written word. Encyclopedia Britannica has its own definition, but I like this one by Gerrit Noordzij that says typography is writing with prefabricated letters, simply because it doesn't tie the definition into any specific medium. Typography as a discipline will continue to evolve as mediums change over time. Letters are mentioned in most of those definitions, and letters are a type of grapheme, which is the smallest unit of a writing system of any given language. Now, the World Writing Systems website presents one glyph of each of the world's writing systems, and it is the first step of the Missing Scripts project, which is a long-term initiative to identify writing systems which are not yet encoded in the Unicode standard. And right now, there are still 146 scripts that cannot be found in Unicode. Now, a large number of the world's writing systems are alphabetic in nature, where a relatively small set of letters can be combined in a myriad of ways to form words, phrases, sentences, all of which become a visual representation of the spoken word. Now, currently, the dominant writing system is the Latin alphabet, originating from Italy in the 7th century. It has its roots in the Etruscan, Greek, and Phoenician alphabet. And the writing system spread with the expansion of the Roman Empire, and yet again in the early modern period, during which massive waves of European colonization of the Americas, of Oceania, parts of Africa and Asia took place, and results in numbers that, look like this, with Chinese and Arabic a very distant second and third, and a geographic distribution that looks like this, where the dark areas represent countries who only use the Latin script. The lighter areas show countries that use the Latin script in addition to others, and even the gray areas have Latin script alphabets as an unofficial second language or transliteration, that sort of thing. Of course, not all Latin scripts use the same alphabet, and neither are alphabets restricted to Latin scripts alone. All 26 letters in the English alphabet are fairly vanilla. No diacritics, no circumflexes, no ligatures, unlike Romanian or German, for example. And we relate this back to typography and the concept of prefabricated letters. When we pick typefaces, be it in the physical or the digital world, there may be instances where a particular character's glyph is missing from the typeface. So what are glyphs then? Well, let's take a look at some examples. This, a very strong, sturdy M, that's a glyph. Oh, look, a lovely collection of pixels, that's also a glyph. Aha, vector image, that can also be a glyph. So a glyph is the specific shape of a letter or character of a particular font. Now, in the digital world where everything is data, glyphs can be described as an array of pixels, collection of vector images, or even paths of Bezier curves and straight lines. And the next question would be, what about fonts? What are those then? Now, fonts can be thought of as collections of glyphs. So in the world of metal typesetting, these are fonts. And some of you may have seen, drawers containing individual metal sorts used for letterpress printing. Now, in the digital world, these are fonts. Specifically, these are font files, and different font formats store information about the font, like their glyphs, their encodings, metadata about their font a little bit differently depending on how the specifications were written. Now, given this is JSHeroes, and I'm clearly not talking about anything related to JavaScript, I will at least keep it related to the web, try to keep things remotely relevant. So content languages on the web. They look like this, where 54% of websites are in English. Now, can you take a guess at how many native English speakers there are in the world today? Anybody? Fine, 5%, right on. So the distribution of languages is much more spread out in the real world than on the web, with Chinese speakers topping the charts about 17% and Spanish coming in next at 6.4%. But writing systems are more than just a means of communication. They're also a reflection of a people's culture, their spirituality, and even their soul. As more and more of our communications move onto the digital realm and into the online world, it is important that we preserve language diversity. It is crucial that a technology meant to be ubiquitous supports creation of local content across the world, and that every writing system in the world can be correctly rendered on the web. So let's assume that Unicode supports the requisite characters for a particular language, and that typeface designers have taken the effort to support that language by designing all the relevant glyphs. So how can we, as people who implement content on the web, make sure that we are doing our part in this effort to make sure languages are presented correctly? Now, we can start by understanding a bit more about digital fonts and typesetting for the web. Declaring a content language on an element is one of the most basic things we can do because it identifies the specific written form of the language to be used in that element, aka the content writing system. Now, this is important because language and writing system conventions affect lots of typographic effects like line breaking, hyphenation, glyph substitution, and so on. So for CSS, language-specific typographic tailorings are only applied when content language is explicitly declared. So it is in our best interest to tell the browser exactly what language our content is in to ensure higher quality typographic experiences for our users. But before we go deeper into typesetting, let's talk about the characters that we're trying to typeset first. So the earliest digital fonts were pixel-based bitmaps. Okay for low-resolution screens, but problematic when content needed to be printed. And one of the solutions to this problem came from Adobe founder John Warnock, who created PostScript in 1985, the very first vector font, and it was really popular. So TrueType, TTF, was Apple and Microsoft's answer to Adobe's font monopoly. Microsoft came up with TrueType Open in '94, and eventually Adobe joined in, and together they developed something called OpenType, OTF. Now, Microsoft also came up with this thing called EOT, or Embedded OpenType, and they tried to submit this as a W3C recommendation, but it was rejected in favor of Web Open Font Format, or WOF. Now, WOF2 is merely an improvement over WOF with significantly better compression rates. So please continue to indulge me in this walk back in time, back to 1996, when CSS first became a W3C recommendation. There was a font properties section defining font family, style, variant, weight, size, plus font as a shorthand. And there was also the, infamous font tag introduced in HTML 3.2 to define font size, color, and face for its content via attributes. Now, this tag is now obsolete. You are advised not to use it, but you do you. Now, you could clearly specify different font families, although they were limited to just system fonts. But not long after, there was a working draft which proposed the possibility of loading font data from external sources via a URL. And this was the earliest public instance I could find of the @Fontface rule. Now, the original 5 font properties, they're still around. They haven't changed all that much, though with the advent of variable fonts, more values are available for use, and much of the latest and greatest can be found in level 4 of the CSS fonts specification. Now, generic font families were introduced in CSS2, and they left it up to the user agents to provide reasonable default choices, which expresses the characteristics of each family as well as possible. It's just really laissez-faire, if you ask me, from the specification writers. Now, there's an algorithm browsers use to determine which fonts to load and use, and even though it expanded quite a lot over the past 2 decades, this is a general idea of what goes on underneath the hood of your browser. Now, if the user agent will first take the first family name defined in the font family property. Now, if it's a generic family keyword, the UA will just pick the one it always uses and load that. Otherwise, it will try to find the family from the fonts declared in @Fontface. Once matched, the UA will assemble a set of font faces in the family, then pick the appropriate font face based on declared font properties. But if no matching face exists, or if the matched face is missing the glyph that needs to be rendered, then the next family is considered. The UA runs through the steps again, and once a font face is matched, the font will be loaded. If all the font family names have been run through and still no font face matches, a system fallback font will be called into play. Now, if a character cannot be displayed using any font at all, for example, this famous or maybe infamous Biang Chinese character, you will end up with a symbol of the missing glyph, like the background. We endearingly call these tofu characters, which personally I see much less of these days, thanks to the widespread use of Unicode. But you know where I see this sort of like blank square characters? When the latest emojis get released and your program doesn't support them yet. That's when I see a lot of these empty squares. So this is an example of the lovely @Fontface rule. And if you've ever tried loading web fonts before, you'd have probably written something similar, and given the support status these days, it's fairly safe to write just WOF and WOF2. Now, some fun facts about the Fontface rule. It may have many descriptors, but only these 2, the font family and source, are mandatory. Now, the font family descriptor works purely like a label, so that we can reference the font data in later CSS declarations. So maybe you're using a font like, say, Helvetica, right? You don't have to call it Helvetica in the font family descriptor. You could call it like Somali, and it would still work, you know? You can name it whatever you want. Now, the source descriptor tells the browser where to find the font data, and it could be an external URL or a local font. The font hint is optional, though. So descriptors for style, weight, stretch, they're used to match styles to a particular typeface in the later CSS declarations. Now, April Fool's Day, a couple weeks ago, if you're as annoying a person as I am, you could swap some font descriptors around, maybe swap the italics and the bolds, and then your teammates will be left utterly perplexed to why all their M elements suddenly turned bold. I mean, if office pranks are your thing, I'm just saying, it's not my fault if you get in trouble. #don't get fired. At this point, I want to shout out the Firefox font tools and the entire team who work on DevTools, because at some point last year, Patrick Brossett, who does a lot of work on the font tools, he pinged me on Twitter about a feature for detecting missing characters. Now, I'm sure he had been thinking about this feature for a long while, but it was still an amazing surprise to me to see that he already had a working prototype the following day. Now, the fonts panel in Firefox has been around for a very long time, possibly since, I don't know, version 24. But over the past 2 years, Firefox has really upped their DevTools game. They've got by far the best grid inspector. They've now got a flexbox inspector, shapes editor, I could go on. But fonts, right? So version 63 shipped with a suite of font tools, including the more polished up version of the font highlighter demonstrated in these tweets. And this is how it looks like in action, where you can see which fonts are loaded on the page and which fonts are loaded for which characters on the page. And there's also information about all the fonts on the page in the bottom section there as well, and you can check on how you wrote your Fontface rule. Now, this tool comes in very handy for me, especially when I have just a handful of words in a foreign language, and the typeface that I picked somehow does not support that language. So, for example, this nice little round sans serif is called Railway, developed by a foundry called the League of Movable Type. It's pretty nice, in my opinion, but it does not support Cyrillic characters. So what we can do here is that we can find a font that does support those characters, and then it still somewhat resembles the design of my original font, and then utilize something called a Unicode range descriptor to create a composite font. Now, it's called a composite font because it mixes glyphs from different fonts for different scripts. Now, to deal with the fact that Railway does not support Cyrillic letters, I use the Unicode range descriptor here to tell the browser to load the other font, load Comforta, when it encounters any Cyrillic characters. So remember that for Fontface rules, the font family is just a label. So what we've done here is create a composite font that uses the name Railway, but in actuality it loads two different font files depending on which characters need to be displayed. And the font highlighter reveals what the browser does when it encounters such a scenario, where Railway is the font family descriptor, but you can see that Firefox is actually loading both Railway and Comforta, and the font tools also reveal which font format the browser is using as well at the bottom part there. Now, CSS for fonts and text, these are typesetting tools for the web. And when you use them in your CSS declarations, imagine that you're running your own print workshop, right? And you're telling your apprentice, in this case your browser, that you need a font of a particular size, a particular style, weight, etc. And then your apprentice runs off to the back room where all the fonts are kept and tries to find the font that best matches your instructions from the descriptors that you assigned in the @Fontface rule. Now, there's quite a bit of work going on with fonts lately, and variable fonts built on top of some of the original properties like weight, style, and stretch to take in newer ranges of variation axis values. But there are plenty more variation axes for designers to play around with. For example, this is a font called Movement. So it uses this additional axis called space. As you can see, if I change the value of space here, the design of the typeface actually changes as well. And I can do it for weight, so there's two axes to play with right now, and this is one single font file. So a lot of possibilities that we have with variable fonts. And sometimes we pick a typeface without realizing that it only had one style. So the browser will try to create bolds or italics on its own, based on the regular font, and the end result isn't that great. So and even under normal circumstances, Chinese fonts, we do not have italic variants for those. So we can set the font synthesis property to a value of none to tell the browser to just leave your beautiful font alone. Now, font feature properties were introduced in fonts level 3, and they allow us to utilize a variety of typographic features like swashes, ligatures, old-style numerals, etc., and these can help maintain typographic color and enhance the reading experience for your users. Now, as long as the font you're using supports these features, you can toggle them with CSS. Now, there's one particular font variant property for East Asian text which allow us to control glyph substitution and positioning for Han characters. Now, I know that probably nobody else reads Chinese, so just take a look at the characters on the screen as I change this value to traditional. The words themselves, they are exactly the same words, but the browser renders the glyphs a little bit differently based on the value. Now, there's also one for Japanese, because Japanese have certain standards called the Japanese Industrial Standard for different glyphs as well. So it's sort of like a subset for Japanese characters, and this is CSS controlled. Now, the user agent will refer to the lang attribute when rendering text, but if a selected font lacks support for that language, we can ask the browser to use typographic conventions of a related language that the font you picked does support. So here's a markup for Macedonian text. So just imagine that the font being used does not support Macedonian, but somehow has the characters for, say, Serbian, which is a related language. So by setting the font language override property to SRB, the Macedonian text will be rendered with Serbian typographic conventions, but still be recognized as Macedonian. Now, a friend of mine, he built a tool that can tell you what features that a font has and the appropriate CSS you can use to toggle them. And it also has the best name of any app I've ever seen. Let me explain. Listen, listen. What can my font do? What can my font do? Eh? Yes, that's why you should check it out. Best name ever. Now, if you're interested in web typography at all, I highly recommend getting a copy of Web Typography by Richard Rutter because it is the most comprehensive resource that I personally know of. This is my own personal copy. And also do watch this great talk by him at CSS Day last year where he goes through all of these golden rules for web typography. And these rules are universal regardless of language, but there are certain language-specific features that CSS can help us address. So most of the time we use text transform for case adjustments and capitalization, but it actually does take into account numerous language-specific case mapping rules. So for example, the German SZ becomes a double S in uppercase, so we can do some toggling. Greek vowels lose their accent when the entire word is uppercase, stuff like that. There's also a value called full-size kana that only applies to the text at the bottom, because this is mostly used for Ruby annotations in the Japanese language. And here we have 5 inline boxes. Now, this situation, there's enough room for all 5 boxes to fit into a single line box. But when there isn't enough room, let me blow up the font size. The inline boxes will be broken across line boxes, and the line break, no, you can't see, anyway, the line break here, this is known as line break. Anyway, these particular lines have been broken due to content wrapping. So we also call it something like a soft wrap break. Now, if wrapping is enabled, the user agent has to minimize the amount of content overflowing a line by wrapping the line at a soft wrap opportunity if one exists. So in English, this is fine. For most writing systems, soft wrap opportunities occur at word boundaries, where spaces or punctuation are used explicitly to separate words. And if you're thinking, breaking lines, how hard can it be? Well, there's a lot of nuance, because word breaking works slightly differently depending on the language we're typesetting for. For example, English wraps at spaces, but for Japanese and Chinese characters, the break is per character, usually, but not always, because line breaks are prohibited before certain punctuation marks. A number of Southeast Asian scripts are written without spaces between words. Then text is wrapped at syllable boundaries in addition to word boundaries. I could go on here. And there is interplay between these 4 properties here to provide developers a little bit more precise control over line breaking, because some rules take precedence over others if both are present, or some only take effect if white space allows wrapping, for example. Now, I highly recommend watching this talk by Florian Rivoal, co-editor of the CSS text specification, because he explains all of this in his talk at .css last year as well. And if you're not sure what's going on at all, or you're all just very confused about all this, just set the lang attribute, because setting the lang attribute takes care of some of this stuff for you. Some, which is better than none. Text justification is not a trivial computer science problem, because I've seen programming assignments for Markov chains asking for text justification algorithms. And whether we realize it or not, most of us would have encountered at least 2 major justification algorithms. We have the greedy algorithm, which analyzes only a single line, and the much more advanced Nuth+ algorithm, which analyzes every line in a paragraph. Now, design software with advanced typesetting capabilities like InDesign, they use Nuth+, but browsers sadly use the simple one. Possibly performance reasons, I don't know. But although we don't have a robust justification algorithm, text level 3 does include the text justify property to allow some further tweaking of justified text. So if I search for text justify web on Google, the top result is titled, don't use fully justified text alignment on your website. And the next result is justify text with HTML and CSS, don't do it. It seems that justified text has a really bad rap on the web. And this might be true for Latin-based scripts, but not so for Chinese characters, which are also known as square characters, because each character is composed within a uniform square, and Chinese text can be typeset into neat rows and columns. In fact, it is ideal to do so. However, when there are both Latin-based alphabets and Chinese characters, it's impossible for everything to line up both vertically and horizontally, so the next best thing is to ensure the start and end of every line is aligned well. So what we can do is we can make adjustments between adjacent typographic character units in Chinese texts with a value called intercharacter, which is so hard to spell. Yeah, so it lines up neatly when it's activated, which is really nice. Now finally, writing systems are not limited to just horizontal top to bottom. Traditionally, East Asian languages were all written vertically. Arabic and Hebrew, they're written from left to right. So the writing mode property specifically caters for vertical writing on the web. And the default is horizontal top to bottom. And to change the direction to vertical, we can use a vertical RL property or vertical LR. There's a sideways option that has been moved to level 4 of the spec, but Firefox already has it implemented, so you can see it right here. And when we rotate lines of text, this affects the individual characters inside the line as well. So again, the lang attribute is very important because browsers are smart enough to tell that Chinese characters which are dual direction will always be displayed upright, while horizontal-only languages will have their characters rotated when vertical. So this text orientation property we have here can be used to make all the characters upright or sideways, depending on what you want. The last property in the set is called text combine upright, which addresses the issues of numerals and abbreviations in vertical text. For example, if your text contains, say, dates. So this property lets us fit all the digits into the width of one character space and display them all upright. And we have this very last value on the right called digits. It has yet to be implemented in any browser, but it really makes sense to have this sort of limit. Let me explain. I mean, 4 digits is probably the maximum you can squeeze into such a tiny space. 7 looks very uncomfortable, and 13 is just ridiculous. So yes, it's good to have a limit here. Now, vertical text may be better suited for East Asian languages when it comes to full-length body copy, but that doesn't mean other languages can't get in on the fun. We see vertically set text in print all the time. Now, headers or short runs of text are actually relatively safe to typeset vertically, and we can add some typographic variety to your web layouts. So for example, if you have a short word here, you can just do upright, something like this. In fact, we can even, combine the writing mode property with, say, transforms. So then you can sort of flip the text around as well. So there are a lot of possibilities with modern CSS these days. Now, I spoke a bit more about East Asian typography because Chinese is my mother tongue, and I'm more involved with the Chinese layout task force. But if you notice on the list at the very corner, there are also layout task forces for numerous other scripts, and this is definitely a step in the right direction when it comes to preserving language diversity on the web. An ideographic language like Chinese was not a good candidate for movable type printing. The calligraphic style of Arabic writing also resulted in efforts to reduce the number of variations of letters and diacritical marks. And such typographical compromises are akin to having the finest sculptures in the world caked in mud and dirt. Now, I think that the digital age presents an opportunity to clean off the dirt and mud of these scripts that have long had to compromise to get with the times. Our digital age is the age of light and electronic signals, and there are far fewer limitations as compared to a physical medium like movable type. So if the virtual world is being touted as a realm with limitless possibilities, then it should be reasonable to expect that all of our scripts can be restored to their full artistic glory on the World Wide Web. 冇辦法。